John Burpo, I'm a graduate researcher in the Biomolecular Materials Lab here at MIT, working for Dr. Angela Belcher. And the main thrust of my project is to create new electrode materials for lithium rechargeable batteries using the M13 filamentous bacteriophage. In the image, what you see is essentially inorganic cobalt oxide nanowires that were synthesized on top of a three-dimensional mesh network of virus that are all cross-linked to one another. We envisioned initially an idealized three-dimensional mesh network, essentially arrayed orthogonally or at 90-degree angles in 3 dimensions. If you relax that requirement for 90 degrees and accept the fact that our virus is a little bit flexible, almost like a spaghetti strand, and imagine a bowl of spaghetti where all the spaghetti strands are the same length and they're oriented randomly within the bowl of spaghetti, and you could almost freeze it to where all those contacts were instantaneously fixed in place with what we call a covalent linkage, then essentially you have a three-dimensional virus hydrogel where water surrounds the virus and it's a squishy gel. We basically use that as a template to grow cobalt oxide or a variety of other inorganic metals or metal oxides for the use of electrodes, which could be used in battery systems, catalysis, and just a broad suite of engineering applications and biomedical applications. One of the things in forming the three-dimensional mesh networks is whether or not that pore structure is actually maintained from the top surface of the scaffold all the way through to the actual substrate or underlying material. What we used is a focused ion beam to etch a hole into that scaffold, and if you burn the hole slow enough, what it should do is preserve the porosity of the cross-linked virus underneath. And that's what we see in the image, to where you see that the scaffold is in fact porous throughout the depth. The great advantage of having a very porous material is that you get a great increase in surface area relative to your volume for an electrode material. And that increased surface area increases the contact with an electrolyte and ultimately should give you better rate, charge and discharge performance of the resulting batteries.